In the previous video, we talked about halogenation of alkanes, and so this is just a quick video on the halogenation of alkenes and a couple differences. So I think in the first video on radicals, we related the bond strength to the stability of the radicals that we're forming. And so in this molecule, we have three different types of hydrogen atoms. So this hydrogen here, if we were to take this guy off and leave a radical, that would leave a vinylic radical, which we talked about being particularly unstable. Removal of this hydrogen would result in a secondary radical that's more stable than the vinylic radical, and so the energy of that bond decreases. If I was to take off this hydrogen and make the radical here, that would make an allylic radical, and that is more stable than the secondary radical, and so that has an even lower bond energy. And so if we conduct hydrogen abstraction to create this allylic radical, it is resonance stabilized. And so we did some examples of drawing these resonance structures in a previous video, and that makes this hydrogen the easiest to remove. And so if we do bromination, which we talked about being much more selective than chlorination, if I do radical halogenation of this compound, we're going to add the bromine here because this is the position that the radical would be the most stable. Now, one potential issue of trying to do radical halogenation of an alkene is that we've got a bunch of Br2 present in the reaction mixture. And in the chapter on alkenes, we know that adding Br2 to an alkene is a possible reaction. And so to avoid this competing alkene addition, if we use this compound, N-bromosuccinimide, or NBS, this eliminates the problem of the competing addition of Br2 to the alkene. So this compound, NBS, serves as an alternate source of bromine radicals. So the reagents would be, NBS and HNu as opposed to Br2 and HNu. And then another issue that we need to be aware of for radical addition to alkenes is in this reaction, we can get two possible products, right? So because the radical intermediate that's formed is resonance stabilized, I have both of these resonance structures being possible, and so we can add the bromine to either one of these carbon atoms. All right, and so I have a follow-up video with some examples of halogenation of both alkanes and alkenes.